Okay, for the first question is to find the standard deviation of the sampling distribution for sample N120, which we have to find the population, the number of vaccine students, and the sample size. So what I did was I divided 600, which is the vaccine of students, and 635, which is the population size, and this would be my answer when I divided that. And then the other step would be you would plot this in here, you multiply by this equation, and it would equal this. Then you divide by the sample size, which is this one. You plot it here, you divide by 120 equals this amount, because 120 is the sample size, so you add it here. Then you do n minus n divided by n minus 1, so it's 635 minus 120. That would equal 515, and then you do 635 minus 1, it would equal 634. So this would equal 881.23. For the step 4 is that you get this, you plot it here, you times it by what you got here, and it would equal this amount. Then you want to find the square root of what you got here, and it would equal 0.0188, but you have to round up, so the final answer is 0.019. And then for question 2 is Greg wants to estimate the percentage of people who lease a car. He surveys 340 individuals and finds that 90 lease less cars. Find the upper bound of the coefficient interval for the population proportion with 95% coefficient level. So this is the chart, and you have to round to the third decimal place. So this is what I did, was that you have to find the sample size, the number of people who leased the car, so it was 90, and the sample proportion, which you would do 90 divided by 340, it would equal 2647, but you have to round up, so it's 0.265. Then you find the coefficient, that above 95. So since we got this here, it would be 1.960, and we would use this formula, right? So for step 2, you would plot these in here, and that would equal 0.2647. So you get 90 from x, like it says here, and n from 340, which is right here. Then you plot these to the standard error formula, and you plot what you got from dividing 90 divided by 340. You plot it here, then you times by the same, and then you minus by the same, and you still divide by 340, right? So it would equal 0.1946, and you still divide, so you equal this, right? Then you want to find the square root of this, which is 0.0239. Then you plot 1.960 times 0.0239, what you got here, and you got this from up here, and that would equal 0.468. And the upper bound is 0.2647. You plus this, and you get this from up here. It would equal 0.311, and since you have to round up to third decimal, it would be 0.312. That would be the answer. And then for question 3, it says a random sample of math majors taking statistics course were surveyed after completing the final exam. They were asked how many times did your reviewer review your final exam before handing it in to your professor. The results are displayed in the probability density function for the random variable x, the number of times students reviewed the exam before handling it. Find the standard deviation of x. So this is a chart and we want to find the standard deviation. So this is what I did. I used this formula. And then you plot these into here. You do 1 times 1/5, which is this. Then you keep doing the same, but you multiply those two. Then you want to add, right? You add at the end. So since you multiply these, you get 1/5 plus 4/5 plus 14/5 equals 19 divided by 5. It would equal 3.8, right? Then you want to calculate this. So this would be the formula from up top, so it's going to be the same. So we do 1 to the power of 2 times 1/5 plus 2 to the power of 2, and then you do 2 divided by 5 plus 7 to the power of 2 times 2/5. Then you get the answer for those. So it would equal 1/5 plus 8/5 plus 98/5 equals 107 for the top, and then you add the bottom stays the same. It would always stay the same. So it would equal 21.4. Then you calculate the variance. So this is the formula we want to use. So you do 21.4 minus 3.8 to the power of 2, which you got here and here. You plot these in here, equals 2.14 minus 14.44, because that's what you got here. Plot it into here, and it would equal 6.96. So you want to get the standard deviation equals 2.64. So this is the answer for number 3. And for question 4, the probability of failing a test is 0.15. If you consider a group of 12 people taking a test on a given day, what is the probability of 2 or more of them will fail the test? So it says round your answer to the 3rd decimal place if necessary. So this is what I did step by step. So we would use this formula. So step 1 is a probability that 0 people fail. So you do 12, 0, and you multiply by 0, so it's the same, and then you multiply it times 12. It would equal, you leave it at 1 times 1 times 0.88512, right? And the probability that 1 person fails, so you would do the same, but you do to the power of 1 here, so it's 1%, and then 11, so you minus that. It would equal 12 times 0.115 times what you got here, so you add it. What you got here, you add it here. And then the step 2 is that you want to multiply by the power of 12. It would equal that. And then you do the same for this one, for the 11. It would equal 0.297. And then the third is px equals 0. It's 0.263. And the fourth step is px equals 1 equals 12.0.297 equals 409, right? And then the step 3, then we calculate the total probability for 0 or 1 failures. So this is the formula, and you want to plot this one, right, for this one, because it's probability of 0. And then you do plus 0.409, which is what we got here for this one, right? You see the resemblance, then this is where you get 0.672. And then the final probability is 0.328. So this is the answer for number 4. And then for question 5, it says, according to a study, 30% of teenagers have tried smoking. A social scientist interested in conducting a research on this topic. What is the probability that of the 50 teenagers sampled, between 15 and 17 of them have tried smoking? Round all number to 2 decimal places using the Z table below. Okay, so this is what I did. The step 1 is you want to find the probability of success, which is 0.3, which is 30%. You just want to add the 0, and it's going to be right here. And then it says the sample size n equals 50, right? And then it says calculate the mean and standard deviation. So we used this. So n times p equals 50 times 3. So pn, you plot it here because it's a formula we want to use. So it would equal 15, right? Then you want to find the standard deviation because this is the mean. The standard deviation is that you plot these right in here. So it would be 50 times 0.3 times 0.7. And 0.7 would be this one. Okay, and that equals 10.5. So you want to find the standard deviation for that. It's 3.24. So this is the answer for this first one. And then it says use a normal approximation. So I use this formula. It says in step 4, calculated probability. So 15 and 17, that's what we got here, right? So you want to plot it in there. And then you want to convert them to standard normal variables, which is C15 equals 15 minus 15 divided by 3.24, which we got when we calculated the mean and standard deviation. And then you would do Z17 because it's 15 and 17. 17 minus 15 minus 3.24 equals 0.62. Then on the last step, we use the Z table. So this is what we got for 0.500. And then this is what we got, 0.732. Then the probability of 15 and 17 is this, the answer, 0.232. So it might be confusing of how I got this, but using the table, I got 0.500 because it's zeros, right? So it would be this one. And then since I got 0.62, so you would do 2 right here, right? Then you go down, and then this would be the 6. So this is how I got 07.73. Then you wanted to subtract these two, so you have your answer like this, and this would be the answer for that. And then for number 6, it says, does the college major depend on whether you are an athletic or not? A survey asked a group of college students about their major. It is also groups that students by whether they are athletes or not. The data are recorded in the contingency table below, and a chi-square test of independence at the 1% significant level is performed. So this is a chart. So you want to find the test statistics, right? And it says round 1 decimal place. So with that table, you know how these are the rows, these are like the column and the row total. So we want to use those. to convert this, to use a chi-square, right? So it would be row total for row I times column total of row column J and grand total. And then for athlete and arts, right? Athlete and arts, so it'd be 36 times 16 divided by 71, because this is the total for both. So you would always divide by 71. It was 8.1. And then for athlete and humanities, 36 times 23 equals 11.7. And then for athlete right here and science, it would be 36 times 32 divided by 71 equals 16.2. And then we would do it for the non-athlete with arts, non-athlete with humanities, and non-athlete with science. So this is what we got for these, right? Then you want to compute the chi-square statistics. So this would be the formula. So then you plot all of these, what you got here. The 11 is because we got it from the E11 square, right? Because it's 11 right here. And then, yes, so you divide by 81. So when you subtract here, you add it here, and you keep adding it here, here, and there, right? So then the answers for these top would be 2.9 to the power of 2. Still going to be to the power of 2. Then you divide by what you had in the bottom, right? And then the total would be, because you already divided these, and then you add 0.14 plus 1.89 plus 0.20 plus 1.06 plus 195 plus 0.21 equals 6.4. So the answer would be 6.4 for number 6. And it says to round 1 decimal place, so that's why it's 6.4. And then for the last question, it says a professor is trying to determine if her students guessed on a certain multiple choice question. She expected that if the students guessed, the distribution of answers would be uniform for that question. She compares and observes the distributions of answers with the uniform distribution. So this is a table, and then it says right there, Deb's had the chi-square goddess to a fit test are summarized below. So they're right here, and then you kind of want to calculate yourself to see if what conclusion can be made and select the apply. And the answer for this one is it's C, that we should reject H0 at the 0.5% significance level. There is sufficient evidence to conclude that the students were not guessing. The outcomes do not occur with equal frequencies. So that would be the answer for number 6.